The first of which is that we need to have two triangles here. So one is a right angle triangle, as you can see. Okay, with it has a square over here. Yes, so this is a right angle triangle, and this one over here is the x. The next one is 5 centimeters from here, and that one is not a right angle triangle. It looks like this. And then we have 40 degrees here, and we have 13 degrees here, 10 here, and we are asked, that's all the information we're given, right? And we're asked to find x. So x is this angle here. Okay, so how can we find that for the remaining? Now, we learned previously in SOHCAHTOA. Remember SOHCAHTOA, we learned that for right angle triangles, I can always find the angle. Yeah? So if I have two sides, I can find the ratio of those two sides. Well, if those two sides are the hypotenuse and the adjacent, then which rule do I use? Which function do I use? Do you remember?
Sine.
Hypotenuse and adjacent. That's ka.
Oh yeah, so
cos. If I have opposite and adjacent, which one do I use?
To.
And then opposite and hypotenuse is sine. Okay. So I think most likely it's clearly going to be the opposite here. Opposite to the angle is this one over here. Yeah, and we're already given the adjacent. And finding the opposite is no difficult job, because that's the cosine. You understand the plan now? So the plan is that I find this side using the cosine rule, and then once I've got this side, I have the adjacent and the opposite, and I can simply use my opposite and adjacent. So that's going to be tau. So it's going to be tan minus 1 of this angle over the other angle. Okay, that's the plan. So do you remember the cosine rule? A squared is equal to. Do you remember?
A squared equals to b squared plus c squared minus 2ab to 2bc and cos a.
Very good. Cos A, that's a capital A. And what did I say about B and C? That which sides do they have to be? Can they be any sides, or do they have to be some particular sides?
They can be any sides.
So if I had this side was given to me, let's say this side was 13. That means my B is 10 and C is 13. It's a question. It's a very important point about B and C. Then that's B and C according to you. Yes? Okay. Well, that is not precisely yet. B and C have to be the two sides in between the angle. So I remember I said this to you, that there have to be two sides, but in between them has to be an angle that's given. Do you remember that? So these are two sides, and in between them is an angle that's given, correct? Therefore B and C have to be these two sides. If I say this is 13, then if I want to make this B and C, then which angle do I have to be given? Tell me. If I call this A, B, C. If I say this is B and C, which angle do I need to be given? I've labelled it so you can tell me from there which angle it is.
Do you need angle B?
This one?
No.
So that's
angle C.
See, this one? Well, to be given this, if I'm given this angle, Zulkarnain, it's a very important point, and we can perhaps reflect on this a bit. If I'm given this angle, then I need to have the two side ones, yeah? You agree with that? So I need to be given this one and this one, but I'm not given that one. So if I'm given those two sides, I'm given this one and that one, which angle is in between them? It's this one here, yeah? ABC, that's how you say it in mathematics. You say ABC. ABC is referring to the angle in between, which is B. So this angle have to be given if this was B and C. It's a very important point that B and C have to be the two sides, and they have to have an angle in between them. Okay? So it's like you have to have two arrows, and those two arrows have to be pointing to the same angle, to one angle, okay? Make sense? You sure? Okay, let me test you again. So if I'm given this to be 13, and I'm given this to be 10, which one do I have to be given now?
C.
This one here? Correct. Very good. Okay. So now let's continue with the question, not go on a further tangent. And remind me, which one were these originally? This was 10 and that was 13? Yes?
Yeah.
Okay, so now that means these are B and C. Doesn't matter which one I call B, which one I call C. It doesn't matter. So that means I can call this B, that C. It doesn't matter. So A squared, which is this angle here is my A. This side here is A, is equal to B squared plus C squared. That's going to be 13 squared plus 10 squared minus 2 times by 10 times by 13. Cos of which angle? 40 degrees. Okay. And then if I do this calculation, it's going to be most likely you have to be given a calculator for this one because you're not required to know this angle. Okay, so let's try to plug it in our calculators, but with a slight adjustment, and that's that. I have to get rid of the square, so I have to make a square root. Okay, let's see who can do it first. I beat you. Okay, 8.35 or 8.36, is that what you get? Check.
8.35.
Okay, so 2 decimal places, that would be 8.36, yeah? So that means this side is 8.36. And that's very clear now. Now I'm given the adjacent. Let me call it a different letter because A is already used. I'm given the adjacent, so I'm going to call it capital A, okay? That's also used. There's a very big problem in using the same letters for two different things in mathematics. So I'm just going to call this something else. I'm going to call it, give me a letter, I don't know, rho, okay? And I'm going to use a different letter for this one, K. So that means I know that tan has the ratio of opposite over adjacent, right? Is equal to opposite over adjacent. Sorry, this is, I forgot the angle x here. A tan of x degrees is equal to opposite, which is 8.36, over adjacent, which is 5 centimeters. And now, how do I find the angle x? Do you remember from there? It's all a review now. Have we done this before?
Yeah, so you move tan minus 1 and then brackets.
So you take the, what is that called, tan minus 1? It's called the, it starts with an I.
Integer.
Inverse.
Oh.
Inverse, okay? Nice try. So it's inverse. So it's going to be 8.36 divided by 5. What does that give you?
Two decimal places.
Right. If you do 2 decimal places, sometimes they write it like this.
It's
okay?
1 decimal place, so it's 1.
We can do 1 decimal place. That's fine. If this, yeah, that's fine. 1 decimal place. Okay, so 15. That's it. Do you understand that? Quite simple. Not much problem solving there, but I mean it's fairly maybe it's tricky at your age, you know. Okay, this 10 looks quite good. 10 looks quite nice, doesn't it? 10 looks good. Let's do 10. And the next one you circled is 11 as well?
Oh no.
Which other one you circled?
Just 9 and 10.
Okay, I thought you said 3. Okay, that's it. Then 10 we're going to do. I'm sure you can do this as well, Zulfiqar. I think perhaps you were just afraid, you got a bit afraid with those letters. And I think in my first lesson I said, now guys, letters, they're just variables, okay? You can call an apple A, you can call a banana B, it doesn't really matter. Okay, these shouldn't really frighten one. So the triangle again with sides. Now this is 60 degrees, yes? This is x plus 2. So if x is 2, this is 4. Okay, so 2x minus 3. They put in brackets, I'll put in brackets as well. And this is root 73. And what is the question? The question is, work out the value of x. How do you think I will do that? I'm not going to proceed with the answer. I know how to do it. How do you think I'll do that? So what is the first thing every time?
You label them.
You label them and then use the
Formula.
formula. Okay, very good. If you're given one angle, you have to use the formula, right? They're asking you to find